Good afternoon, since I realized you're going to be seeing this in the afternoon. Duh. Um, yeah, hello. I just sent out an email. It's Monday night, and really hope that you read it. Really hope that you give me that feedback. As I said in the email, you can email me, or you can go into forums and let me know. Either way. But I'd really like to know what's going on with you so I can do this better. Okay, on to sampling. Sampling is a big deal. Um, it's not easy. And my argument here is when you study part of a population, a sample, to learn about all of it, you really need careful design. You do need to do a lot of planning. There's a number of elements. Today, I won't be going into part of the reading. The part of the reading was probability sampling, and then Wednesday's reading, no, next Monday's reading is non-probability sampling. I'm doing those two types next Monday. This is just the background on all sampling. Okay, samples are pretty standard in social science for very good reason. It's almost all research in the social sciences is done based on sampling. The reason is doing a census is impossible. It's obviously not impossible because we're doing one this year, but that's the United States government. That's not, say, me, Thomas Burr, studying bicycles around the world everywhere. I can't. There's no way. So these definitions, A and B, will help us get to C, which is what I just said. I'll say it again. So a census is measuring something, observing, asking from every person in the population, every single one. A sample is measuring or observing or asking only some people in the population. That that's what it all boils down to. That's why you have to plan sampling so carefully. If you do not ask everyone, do you really know? If you are wanting to know who's going to win this fall, Trump or Biden, or I mean, Sanders still has an outside chance given the latest controversy about Biden. But let's say it's Trump versus Biden. Um, do polling. They just did a poll about that. Um, this is Monday night. You'll be hearing this Wednesday afternoon. Are you going to call 325 million Americans? No, you're not. Nobody has the money. You call 1,000 people, and then you talk about a margin of error, and you hope it's representative. All things which we'll get to. That's the problem. How well can you trust that poll? Because you're taking a sample. You're not asking all 325 million Americans. That's why sampling is so important. That's why we have to be careful. So, governments have the resources to do censuses. The Bible in Gospel of Luke, chapter 2, verses 1 through 5, mentions a census that the Roman government, the local Roman government, did. And that's sort of the setup for explaining why Mary and Joseph had to go somewhere to register for the census, and that's why they were in that town when Mary gave birth. That was 2,000 years ago. Governments have been doing censuses even before the Romans, so 4,000 years. The U.S. government does a census, as I said, this year. They do it every 10 years. It's not law, it's the Constitution. Even more important than law. Must do a census, count every person every 10 years. Get some data on each person. You don't get a total biography and you ask them everything. You ask only a few questions. And there's in the census, they do a deep dive on some people that ask them more questions. Even the government can't ask everybody all the questions they want to ask. They sample within the census. But there's no way that scholars can gather that amount of data. Governments have the tax dollars and therefore can hire the staff to do that. And other governments do that. The Russians do it. The French do it. Brazilians, the Chinese, everybody, most governments do a census on different schedules. I think the French are every 5 years, or somebody's every 5 years, and somebody's every 15 years. We're every 10 years. Even when governments publish census data, and as I said, governments will sample within the census, then scholars will sample within the census data that the government publishes. I mean, it's your tax dollars at work. It should be public information. So, and the really private information is locked down for a certain number of decades, and then it becomes open. So if you want to know the names of people 100 years ago, you can't. I don't know what the year is, but at some point it goes from private to totally public. No, like the names are private. The other data is public right away. So for point D, Frank Beck this fall, when some of you take his class, will only be talking about 10 Illinois cities. He will not be using the entire database that the US government provides. He'll be sampling from the census. Will we be able to make generalizations? Will he and you be able to make generalizations about all American cities? Probably not. Will he and you be able to make generalizations about cities in Illinois? Maybe. So even when you have a census, you have to do a sample because it's so overwhelming to do a census. But again, you have that problem. Can you trust information about some of the population to tell you about all of the population? That's a real problem. So you have to do this really carefully. Also, it's worth thinking about sampling in daily life. One example I gave you a couple days ago, give it again. The World War II fighter plane study. British and American planes would come back and they'd be all shot up, and the pilot had some harrowing story, and so they did a study about all of them and found there were patterns in where they were shot. And one of the researchers said, whoa, we are not looking at the ones that didn't make it. They were all ready to put armor where the bullet holes were on the planes that came back. And he said, no, you need to put more armor where there are no bullet holes, because that's what downed those planes. That's why they didn't come back. And lo and behold, they thought about it. It's like, oh, yeah, there's never any bullet holes on the plane right around the engine when it comes back. There's never any bullet holes right around the cockpit when it comes back. Well, duh. They shot the engine up and it didn't work. They shot the pilot. He's dead. Of course the plane went down. But we don't have those planes, so we can't see it. We have to infer it. But they did armor them up his way, and it worked. So he was thinking in census terms. This is called survivorship bias, but survivorship bias means you are unconsciously thinking. You're drawing conclusions from your sample, and your sample is biased. Abraham Wald, the one guy who objected and said, let's think about all the planes that went away. He's thinking in census terms, and he's saying our sample is skewed. Look, the other half that didn't make it, that's the ones we need to think about. Does that make sense? And that sounds like a really obscure daily life way of thinking, but in fact, you meet somebody from a group, and like a new ethnic group, somebody from another part of the country, somebody from a different age group, and you make inferences, conclusions about all those people from this one person you met. Really? So that is a very practical way to think about sampling. You've drawn conclusions based on meeting one person or two people or three people about an entire group. Don't do that. Think about a census. Sample versus census. The point of collecting data is to make generalizations. Well, not everybody agrees with that, and we'll get to that. But mostly that's what you're trying to do. You're trying to collect data on a sample, and that'll allow you to make generalizations about the population. But obviously at this point you can tell that's really risky because any number of reasons could make that sample not tell you accurately about the population. So you got to plan really carefully. First step in planning really carefully is understanding the basic concepts. Okay. 2 of these are review right away, but I'm doing it anyway. Population, the entire set of individuals to be studied. You may want to study the Amish in the United States, all the Amish. Maybe you only want to study the Amish in Illinois. Did you know that there's a big population southeast of here, southwest of Champaign-Urbana, southeast of Bloomington Normal, of Amish? And their numbers are growing dramatically. No birth control. The birth rate's like 5 to 7 per woman. Yeah. And they're really growing. So you might want to study them. You might want to study queer people in North America, which means Canada and the United States, and sometimes Mexico and sometimes not. Maybe you want to study Midwesterners for some reason. You've got to define the population first. Next fall, Marie Schmeckley, are you going to be defining the population as only sociology majors? Or are you going to define the population as only ISU sociology majors? Who are you trying to study? If Maria publishes this data, these conclusions, will people around the country in sociology departments infer that they can apply these findings to their students? Don't know. Okay, sample. That's the subset of the population actually studied. You're not studying, you're not doing a sample, you're not doing the whole population, you're studying only a sample. They're the ones you're collecting data on. Okay, sampling frame. This is important. Remember this. Excuse me. A list of all the elements or individuals in the population. Elements. Remember this word. The unit you're sampling is an element. That's what's sampled. So sociology majors, well, those are people. You're sociology majors. You are people. So you are elements. You can do this. Very standard in say population biology instead of sociology. You're looking at animals. The elements would be animals. The elements would be viruses, to go back to the news. But a sampling frame, and you can tell it's really hard to get a list of all the elements. It's kind of like you're preparing for a census and then not doing it. You have a list of everyone in the population. I'm going to be really leaning on this idea of a sampling frame because it's very important. So memorize, sampling frame, list of everybody in the population. Enumeration units, units containing elements. So the enumeration units are not the ones you're sampling. They're things you have to deal with in order to sample. And the example, I believe, in the reading is schools and teachers. So the enumeration units are the schools. The elements are the teachers. You're doing a study on teachers. You're doing a study on classrooms. Instead of teachers, you're doing a study on classroom interaction between teachers and students, or between students and teaching assistant. Or it's in elementary education and you're looking at those interns who are elementary education majors in their last semester. They leave campus their last semester and they go into a classroom. Another way could be units. The enumeration units would be households, and if the individuals are in a household. Now, this gets maybe Interesting because something like 25% of all households in this country contain one person. This household, the one I'm in, contains 3 people. Me, my wife Gabby, and my wife Lisa, and my daughter Gabby, our daughter Gabby. So that's a household of 3. If they are trying to sample individuals as elements, they're talking about me and Lisa and Gabby. You get the idea. Enumeration units are not the same as elements. Now, sampling units, I know, it's beginning to get confusing. This is when you do multi-stage sampling. When you have to sample and then sample again at a lower level. So again, in the example in the text, you can't study every single school in the country. Oh, even the state. Every single elementary school in Illinois. It'll be hard enough to do every single elementary school in Unit 5, which is the local school district. There are actually 2. One's District 87, one's Unit 5. But just try to get some data at the classroom level from every single elementary school in Bloomington Normal. And Unit 5 extends beyond Bloomington Normal into the countryside around. So what you would do is you would, say, pick 2 school districts. Unit 5, District 87. Don't ask me why one's called unit, one's called district. I've been wondering that since we moved here. But those are your sample, those 2 districts. Then you have to sample some elementary schools. Which elementary schools are you going to pick? That's a sample out of your, it's a subsample out of your sample. Those are sampling units. And then you pick classrooms within each school. You're not going to, let's say, 3rd grade. Gabby went to Glen School, and they usually have like two classrooms per grade. Glen is a really small school. If any of you are townies and you went here, you'll know that. But most of you won't. Glen, never heard of it. So, some elementary schools might have 5 classrooms per grade. That in Wilmington, Delaware, when I went there, that was pretty much standard. 4 or 5 classrooms per grade when I was in elementary school. So you would have to figure out, do we pick the smaller school and pick 2 classrooms, or do we pick the larger school and pick 2 classrooms out of 5 instead of 2 classrooms out of 2? This is the sort of thing you have to think through when you're doing sampling, depending on your question. Your question may be completely different. So the next step is evaluating generalizability, or the possibility that you can make general statements from your specific findings. There are 2 types. And the first one is the one we always have to think about, from the sample to the population from which it is drawn. Is the sample representative? Does it stand for, represent, look like the population? So, for instance, if you were to try to draw a representative sample of Americans and you had 100 people to work with, I forget how many white people. You would need 13 black people, 18 Latinx, 1 Native American, 6 Asians, and I'm not sure how many of them would be East Asian and how many would be South Asian. I'm not even sure we have many Central Asians or West Asians, and West Asians are also known as Middle Easterners. Maybe 1. So you haven't even looked at other aspects of your elements. That's ethno-racial composition is only one possibility. Then there's gender or sex. Are you going to go with sex? In which case you need to make sure you ask about intersex people. If you're going to go with gender, how many categories? We're long beyond 2 categories, masculine and feminine. We're way past that. How many categories are you going to have? In 100 people, I don't know. They're like The numbers are all over the place on transgender people right now. I've seen estimates as high as 1.7% of the population. So 2 of your 100 people to represent all Americans have to be transgendered. I've seen other numbers that are way lower. We're not even sure. Now add social class. Now add political affiliation. Something like a third need to be Democrats, another third need to be Republicans, and a good chunk need to be apolitical, like Gabby. Totally disinterested in politics, government, everything. Don't care. It affects me, fine, I don't care. It drives me crazy. But too bad. If they don't like it, what I think of it doesn't matter. They are apolitical and they need to be part of your sample. So can you see why social scientists try to get the largest sample possible? 1,000 people to represent all Americans would be way better. Then you could get to these finer distinctions like different political patterns and different classes, different social classes. Regional, 2/3 of the population is east of the Mississippi. That blew me away when I was living in California, because California is the most populated state. It's almost 40 million people, but the bulk of America is east of the Mississippi. So you'd have to, for your representative sample, it would have to include people from, most people, 2/3 of the sample would have to be from east of the Mississippi. You get the idea. That's what representative looks like. You really always want to be able to say, if you can, my sample looks like, stands for, represents the population. You don't always go for cross-population generalizability. Sometimes you do, sometimes you don't. Back to the news. Does research in China on COVID-19 tell us anything about how it works here in the United States? At first, it seemed like, nah, men are dying so much more, like 2.5% versus 1.5%. So 1.5% of women get it, they die. That's great. 98.5% live. 2.5%, 3% of men who get it die. Way higher numbers. But then you think, okay, something like 50% of Chinese men smoke cigarettes. The rates for Chinese women are like 2 or 3%. So that must be it. The Chinese population is unique. Chinese men smoke, Chinese women don't. That's why these people, these men who have a respiratory disease, it really attacks the lungs, they're dying at a high rate. So America, smoking rates between the genders are not even, but closer, much, much closer. And smoking rates are way lower. So men are going to be not nearly as vulnerable as women, as Chinese men, American men will not be as vulnerable. Wrong. It turns out it is generalizable. Yes, more men in countries in Europe and in the United States are dying of this thing than women are. Maybe it's not cigarettes. Maybe it is generalizable from one population to another. So that's always a question. You really need to wonder, once you have results in a sample, you first wonder, well, did I get the population right? Second, will this work on another population? Those are really important questions. Okay, sampling error. No sample is perfectly representative. There is only one way to do a study that is perfectly representative of a population, and that is to do a census. And since we're not, you're going to have a sample error. There's going to be a difference between what your sample looks like and the larger population from which it is drawn. There's just going to be that. You try to drive the sampling error down as much as you can. You make it as small as possible, but it's going to exist. And finally, I've already talked about this, but now here's the name for it. The target population. The population I want to study. The population to which you will generalize findings from your sample. That's, as I said before, and I'm going to say it again, I'm going to repeat myself, you absolutely have to define this before you think about sampling. Who am I trying to study? The third step is to assess the population diversity. I've given you plenty of examples now, so you get the idea. But the book, this is always, I've always objected to this. The book says, and I object every semester, atoms and animals are the same, so you don't need to worry about sampling. You just study animals, and you can infer from the animals you study to the animals you haven't studied in the larger animal population. This is written by a guy who's never had a pet, as far as I can tell. Oh my God. Animals are different. Now, biologically, okay, maybe that's true. In terms of personality, I mean, right now I'm looking at a cat that's trying to get in, and I'm going to be a jerk to him and ignore him because I call him the bad kitty. He's a jerk. He's very annoying. The cat I was referring to earlier is Ava. She and her brother Milo are the sweetest animals Lisa and I have ever had. And Lisa and I are getting on our 25th wedding anniversary this summer. That's quite a few animals. And you can tell we have 3 cats and a dog. That was not my idea. Anyway, these animals are very different. I would say animal characteristics would matter, but I have to agree with the author to mostly, certainly to a degree and maybe mostly, that the differences between particular animals and the differences between humans are much larger. The animals are smaller, the differences between people much larger. You can speak cat in any other country and it's pretty much cat, whereas languages, just languages in human societies are, I mean, there's thousands of them. So you've already gotten the idea from what I've said, what a representative sample looks like. But here's the actual definition. It looks like the source population in all relevant characteristics. As I'm writing up this lecture to speak it into audio, I realize that I'm getting ahead kind of and repeating myself. And you know what? That's fine. You already had examples. Now here's the actual definition. But the key word here, now that I'm defining it, the book is defining it, and I'm going over it. The key word is relevant. Do you know the relevant characteristics? For instance, you're doing a study on COVID-19. I bet the virus doesn't care if you're gay or straight. I don't think it cares if you're a lesbian or a gay man, or you're straight, or you're bi, or you're asexual. It's probably going to work the same in every body. And I mean that body. Now, will sexuality matter in the way you got it? It's not a sexually transmitted disease, so gay people and straight people can give it to each other because they're shaking hands, they're using the same surface. You've got a gay stalker at a grocery store, and it doesn't matter that he's gay because he's just stocking the shelves, and a straight person comes and buys what's on the shelf. But people who are like each other tend to hang out together. So it might go in particular social networks. That's when sexuality might matter in a study of how this thing is spreading. It's your social patterns from your sexuality. So is that a relevant characteristic? That your sexuality, is that a relevant characteristic in this sort of study? If you're a doctor instead of a sociologist, you might miss that. Any good person who's trained in public health will not miss the possibility that gender, sexuality, ethnicity, race, class will affect who gets COVID-19 and how. It may really not matter. Any one of those may not matter. Everybody's at equal risk. I seriously doubt that. But the point is, for this, do you know which characteristics are relevant? The main characteristic next fall for Mia-Schmeckley will be declared major in sociology or not. The main characteristics next fall for Frank Beck will be race. To what degree is that cultural? Because if race is socially constructed, and I could get into it, but I won't. But all of you are pretty likely to be on board with that. To what degree is it cultural? And what elements of dominant white culture matter and what don't? What elements of Asian culture matter? In other words, are these characteristics of these populations relevant? And that's where sampling can go bad. I think you get the idea. Okay, we're almost done. There are two basic types of sampling: probability sampling and non-probability sampling. And there's a problem with both, but it's kind of worse with probability sampling. So, what is probability sampling? The chance of selection is calculable. You can calculate the likelihood any element will be selected. So, you have a coin, you flip a coin, the likelihood of it landing head or tails is always 0.5. And there's all sorts of math. This is a perennial problem in math, and mathematicians like to talk about. It doesn't matter how many times you have a run of tails. The chance that it's going to be heads on the next flip is 0.5. So that's what we mean by the likelihood of the element being selected. So in a population of, let's round it out to 300 million, and you're going to do 3,000 people, the chances of any one American being chosen are I don't know how many zeros, 1. Let's use Illinois State. Okay, undergrads, 17,000 and some change. 17,005, 17,250, something like that. Undergraduate students, not yet gotten their bachelor's degree here at Illinois State, pretty much every semester over the last few years, somewhere between 17 and 18,000. Let's call it 17.5. If you do a sample of 175, that's a 1% chance of being selected. No, it's a 0.1. 0.1? Yeah, it's 0.1. If it's 17, no, it's not 0.1. It's a 1% chance, because 10% chance if your sample size is 1,750. There we go. So you are able to run the numbers. You calculate there is a 1% chance that our 175, that you will be included in the 175 in this sample. So the way to do that, the way to calculate it, is to have a total number of the population and then divide by the sample, and there you go. The other issue is random sampling, and this is always harder to explain. I think students really get it. I think I did well by really pushing census versus sample. But I've never been able to find a way to really clarify random sampling. The best I can do is to say that any way you pick a sample besides random sampling is going to introduce bias, which means it won't look like the population. Okay. One of the reasons you calculate the likelihood of selection is that any element has an equal chance of being selected when it's truly random. And there's lots of ways to randomize. You can just generate a random, there's calculators that just generate a random number table. Online, you can probably find it. But the purpose of random sampling, to get back to my main point, the purpose of random sampling is to create a representative sample, a sample that looks like the population, all in relevant characteristics, and any other method besides true randomness introduces bias, which means it doesn't look like the population. Too many men, too many women, too many, you get the idea. It doesn't matter who. Random sampling is not the best sample drawing strategy. It's the least bad. All other sample strategies are worse. They will bias in some way. Randomness gives you an equal chance, which means you're most likely to choose a representative sample. Now, non-probability sampling means you don't know. You don't know how big the population is. Let's say it's the 1950s. Let's use queer people and let's call them homosexuals because that was the common term in the 1950s. Yes, they called themselves gay. I don't know if they called themselves queer, but so many people were in the closet and you don't even know. Alfred Kinsey is doing his research and estimating, but he doesn't really know because you have so many social incentives, so many reasons to keep your damn mouth shut, up to and including being killed. Certainly losing your job, getting divorced, becoming homeless, nobody talking to you. It was bad. Our environment is so different. So in the 1950s, if you're trying to draw a sample of homosexuals, because that's how they talk about it, you don't really know. You can't do a random sample because you don't have a sampling frame, which means you cannot calculate the chance of being selected for the sample. You're totally operating in the dark. So you really don't know if it's representative. It could be. Chances are really, really good that it's not. But it could be. You don't know. So how trustworthy are your results in the sample to talk about the population? That's the real trouble. Now, it looks like when you put it this way, non-probability sampling is a blatantly inferior way to sample, that you should always try to do probability sampling. In fact, that's not true. In reality, life isn't that simple. And there are a lot of good uses for a non-probability sample. So one would be the example that I was talking about. If you're trying to understand gay life, queer life, homosexual life in the 1950s in the United States, when people are so heavily closeted, in a few places they're not, sorry, excuse me, but mostly are. You're doing a descriptive exploratory study. You're really early in studying this. You just don't know much. I mean, sexuality studies are pretty few and far between in the United States at this point. So you're just trying to get whatever data you can at all. And then a non-probability sample is perfectly good for that. It's really, really useful. It sort of establishes a baseline of data. And then you can say, okay, we knew that about this group. Then we did another set of research in another city and we found something overlapping, but not all the same. Then you build out from there. And even if all the samples are non-probability samples, if you keep hearing the same things over and over, then you're going to start to think, well, maybe those results are generalizable. So you don't get discouraged if you can't do a probability sample. The other thing is that I say non-response, item C, is a problem in non-probability and probability sampling. But really, you're just not too concerned. You're not as concerned in non-probability sampling as you are in probability sampling. Non-response is a huge issue. You can draw a beautiful sample. You've done your homework backwards and forwards and sideways. I don't think the textbook, or for that matter, social scientists in general, emphasize how badly non-response rates can mess with your results. If only a third reply, how do you know the repliers are biased? You don't. You'd need to make sure everybody answers the damn questions, and you can't do that according to human subjects research, which we'll get to at the end of research design. If you're trying to do a survey, you can't make people answer surveys. They have the right to say no, which means you can have a huge non-response rate, which means can you really trust your results? So if you pay close attention to the characteristics of those who did respond, maybe you can say, oh, you know what? They are kind of representative anyway. That's fine. We'll trust this low response rate because they look like our population. Then we're back to the question of all relevant characteristics. Do you know? In a study of homosexuality in the 1950s, people have stuff to hide. Maybe they won't even answer a survey. You don't know. So the very willingness to be researched is possibly part of the answer to your questions. So, an adultery study, a crime study, bathroom habits, any sensitive topic, non-response might mean you're missing relevant characteristics. Okay, so this is to be continued. Even though you read about probability sampling today, I'm just going to make sure, God, I'm already at 42 minutes. I'm not going to go any farther. Don't want to torture you more than I have to. So I think now you get the idea. Studying part of a population to learn about all the population requires a lot of planning. And we're not done the planning. So I'll talk to you about this next Monday.